Alright, so let's start with this. So we have indices. So let's look at these 5 questions from indices. So question 1 says that 27 over 8, everything raised to power minus 4 over 3. Alright, so now this is a basic indices question. So we should be able to solve this using a law of indices. I want to believe that we all know the laws of indices because there is no time to really go over everything again. But very quickly, whenever we have a over b raised to power minus x over y, what we are expected to do is take the y root of a over b, then everything raised to power minus x over y, right? And from here, because of this minus, sorry, we don't have x, it's not supposed to be x over y again, just x, since we're already taking the y root. So we have this now. So we have the y root of a over b, everything raised to power minus x. Now because of this minus, remember, according to the law of indices, whenever you have a raised to power minus x, it is equal to 1 over a raised to power of x, right? So the same thing for this one. That means it's going to be 1 over the y root of a over b raised to power of x. So now let's apply this to this one. So now applying it here, we're going to have the third root or the cube root of 27 over 8, then everything raised to power of minus 4. Then from here, because of the minus that we have here, it's going to be 1 over everything that we have in the bracket, which is 27 over 8 raised to power 4. What is now our final answer? So now to continue here, we're going to look for a number that when we multiply it 3 times, it gives us 27, and when we multiply it 3 times, also that another number gives us 8. So now we have 27 over 8. If we should multiply 3 times 3 times 3, it gives us 27, and if we should multiply 2 times 2 times 2, it gives us 8. So basically this is equal to 3 raised to power 3 over 2 raised to power 3, right? So now whenever you're looking for the cube root of something, let's say we have cube root of 27 now, it is just going to be equal to 3 because we are looking for a number that will multiply 3 times, that is going to give us 27. Just the same way you have square root. The square root now means that we are taking the second root. So is it that you can choose to put 2 here or not, it's your decision, right? So if you don't put 2, let's say you just have your square root, and then we have something like 4, is equal to 2, abi? Because we have 2 times 2 equals to 2 raised to power 2, basically, right? So that's the entire idea behind this. So we have 1 over the cube root of 27 over 8, which is going to be 3 over 2 raised to the power of 4. So now we're going to take 3 raised to the power 4 and 2 raised to the power 4. So here we have 1 over 3 raised to the power 4 over 2 raised to the power 4. 3 raised to the power 4 will give us 81. So we have 1 over 81 over 16. Yes. So now, but this is not our final answer. Depending if your option is like this, then you can go with this. But this is not our final answer. So here we have 1 divided by 81 over 16, and that's equal to 1 times 16 over 81. And our final answer for this question is going to be 16 over 81. So it is that simple. Let me just clean this. You can pause to write. Let me increase the thickness. Alright. Alright. Okay, so let's go to question 2. So question 2 says solve simultaneously, find x and y. So for the first equation, we have 3x is equal to 9 raised to power n. So it's supposed to be, okay, because I could not get y raised to power y, so I had to use n. Well, so we have 3x equals to 9 raised to power y. Then for the second, this one is equation 1. Then for the second equation, we have 8 raised to power y is equal to 2 raised to power x plus 2. 2 raised to power x plus 2, and this is equation 2. This is equation 2. So what we're going to do here is that we'll take this first equation, right? So we have 3 raised to power x is equal to 9 raised to power 9. 9 raised to power y. We're going to break this down to eliminate these bases. These 3, we refer them to them as bases, and while this x and y, they are the powers of those bases. So now we are going to break this base down so that we don't have any base, we just have x and y, right? And to do that, we have to check them, right? This 3 now, we can make y to be 3 raised to power something, right? So we can make it to be 3 raised to power 2, and once we do that, we'll be able to cancel out the base. So we have 3 raised to power x is equal to 3 raised to power 2 then raised to power y, right? So this is going to be 3 raised to power x is equal to 3 raised to power 2y. Because the base are the same, you cancel out. Whenever the base are the same, you can cancel out, right? It's the same thing when you have 4 raised to power 2 is equal to 4 raised to power x. Since the base is the same, you cancel out, and 2 is equal to x. It's that simple. So for here now, we have x is equal to 2y. This is equation 3. We will need it to solve the question. So now let's go to equation 2. We're going to be doing the same thing. So 8 raised to power y is equal to 2 raised to power x plus 2. So now here we can make 8 to be 2 raised to power 3. So we're going to do that. 2 raised to power 3 y is equal to 2 raised to power x plus 2. 2 we cancel out 2. And what we have left is 3y is equal to x plus 2. This is equation 4. Alright, so now that I've gotten this, so here we already from equation 1 we have x equals to 2y. So wherever we see x in equation 4, we're going to put 2y, right? Because x equals to 2y, so we can get the value of x. So 3y is equal to x, which is 2y, equals to 2y plus 2. So we can bring this one to this side, so it will be negative. So we have 3y minus 2y is equal to 2. Then we have 3y minus 2y, that's what y, and that's equal to 2. So our value for y is equal to 2. So now let's find our value for x. From here, we have that x is equal to 2y. So that means x is equal to 2. What's the value of y? 2. So x is equal to 4. So now we have found our value of x and y. So x is equal to 4, y is equal to 2. And that's our answer. You can pause to write down. Don't want it to be too lengthy, so I'm just going to clean it and we'll continue. Alright, okay, so let's go to question 3. Question 3 now says in bracket 2 raised to power 3 multiplied by 2 raised to power x minus 2 is equal to 2 raised to power x squared. 2 raised to power x squared. So this is the question now. So let's solve. So from this one now, according to a lot of indices, whenever we have a raised to power x multiplied by a raised to power b, it is equal to a raised to power x plus b, right? So now coming here, this bracket is telling us that we're supposed to multiply what is here and what is here. The only time you can multiply like this is when the base are the same. When the base are the same, like here you have a and a, so it's the same. But if you have a raised to power x times b raised to power y, they cannot multiply because the base are not the same. So for this one now, the base are the same, so we can multiply, right? So this will be 2 raised to power 3 plus x minus 2, right? Because the powers we add themselves once the base are the same. And this is equal to what? 2 raised to power x squared, right? So here we have 2 raised to power 3 minus 2 give us 1. That's 1 plus x is equal to 2 raised to power x squared. So the base are the same here. We'll cancel out. So we have 1 plus x is equal to x squared. This is a quadratic equation. Let's bring these ones to this other side. So we have x squared is x squared minus x minus 1 is equal to 0. And so from now here, we can just solve our quadratic equation. We can factorize from here. So let us factorize here. So we're going to look for two numbers that when we add them together, they give us minus 1. When we add them, they give us minus 1, and when we multiply them, they also give us minus 1. I don't think we can easily get that number. So let's just use the formula method, the general formula. So x is equal to minus b plus or minus root b squared minus 4ac over 2a. So now that we have that, our a here is going to be the number that is at the back of x squared. What's the number here? 1, right? Even though we don't put it, but 1 is there. So a is equal to 1. Then b is equal to minus 1. Minus 1. Don't make the mistake and omit this minus. It's very important. If it was plus, then you just use 1, right? Because plus 1, 1 is still the same thing. But because of this minus that is here, that minus 1 is very important. Then c is also equal to minus 1. So we just put our values in this formula and we solve. So x is equal to minus b, which is minus 1. So minus times minus 1. So we have minus here, minus 1 here, plus or minus minus 1 square minus 4. Then a is what? 1. Then c is minus 1. So we draw the, okay. Then we have 2. Our a is 1. So x now will be equal to minus times minus, which is 1, plus or minus our root. We have minus 1 square, which is going to be 1. Then we have minus 4 times 1 times minus 1. That will give us plus 4 all over 2. So our x will be equal to 1 plus root 5 over 2, or 1 minus root 5 over 2. So you can see that it was not possible to factorize it because of this square root that we were going to have. But if it was something that is factorizable, just factorize. But if you are not sure on the values that you are using to factorize, just use this method, because you will always be sure that you will get an accurate answer here when you use your general formula. So these are the values of x. These are the values of x. So I'm going to go ahead and clean this up. Alright, so let's do number 4 now. So number 4 says which is true. So the option A, we have 1 over 9 raised to power 3 is less than 1 over 8 raised to power 3, and 1 over 9 raised to power 3 is greater than 1 over 8 raised to power 3. We have 1 over 9 raised to power 3 is equal to 1 over 8 raised to power 3. And option D, we have none of the above. None of the above. Alright, so very quickly now, I'm trying to see how we can possibly solve these questions without calculator, right? Because we will not be allowed calculator in the exams, right? So since we started, we have not used calculator. Let's not start now. So now 1 over 9 raised to power 3 is less than 1 over 8 raised to power 3. Now, already we know for a fact that 9 raised to power 3 is going to be greater than 8 raised to power 3, right? But that's not what the question is asking for. Say which of these is true. Now, we know that 1 over 9 raised to power 3, it cannot be 1 over x raised to power 3. It's not possible, right? It's just like saying 1 is equal to 2. It is not possible. So this one is wrong. So now let's look at option A and option B. So now for option A, we have 1 over 9 raised to power 3 is less than 1 over 8 raised to power 3. Now we know that 9 raised to power 3 is bigger than 8 raised to power 3. True or false? True. So now let's say that 9 raised to power 3 is equal to 2, right? We're just assuming it's not equal to 2, but we're just saying that it is equal to 2. Then 8 raised to power 3, let's say it is equal to 1, right? Let's say it's equal to 1. We're just using this to illustrate, because 2 is bigger than 1, right? And 9 raised to power 3 is bigger than 8 raised to power 3. So now if we say 1 over 2, 1 over 2 is 0.5, and if you say 1 over 1, 1 over 1 is 1, right? So even though 9 over 3 is bigger, right, the inverse, which is 1 over 2, is smaller than 8 raised to power 3. So this tells us that the inverse of a bigger number is smaller than the inverse of a smaller number. So just like this one now, we have 1 over 9 raised to power 3. It is going to be smaller than 1 over 8 raised to power 3, because 8 raised to power 3 is smaller, right? The inverse of a bigger number is smaller than the inverse of a smaller number. So this is going to be the correct answer, because the inverse of 9 over 3 is smaller than the inverse of 8 over 3. So option A is going to be the correct answer for that question. Alright, so question 5. We have 3 raised to power 2x minus 1 is equal to 9 raised to power 3x minus 1. We should be able to solve this. You can go ahead and pause the video, solve, then you continue. Alright, to check your answer. So for this one now, 3 raised to power 2x minus 1 is equal to 9 raised to power 3x minus 1. So I already said that we will try to make the base equal, so we can cancel them out and solve for the powers, right? So we have 3 raised to power 2x minus 1. We know that 9 is 3 raised to power 2. So 3 raised to power 2, we have 3x minus 1. So we have 3 raised to power 2x minus 1 is equal to 3 raised to power. This 2 that is here is going to multiply everything outside this place, because they are powers. They are both powers, so they can multiply themselves. So we have 6x minus 2. Now the base can cancel out themselves. So we have 2x minus 1 is equal to 6x minus 2. This 6x will come here. So we have 2x minus 6x. This minus 1 will come here. Is equal to minus 2 plus 1. So here we have minus 4x is equal to minus 1. And x is equal to minus 1 over 4. And x is equal to 1 over 4. chicken house, and that's our answer. You might see 0.5 in the options, but you should know already.